code. Okay, so I'm going to talk to you about double free. And the way this came about was Roger, I think it was Roger, emailed me and said, hey, you've got a subject you want to talk about. And I was sitting in a hospital room in Dresden Hospital in Germany, terrified because my server kept falling over. My live server was falling over and I didn't know why. And a couple of hours after I got that email, I found a double free, which is the thing I'm actually most terrified of in my code. And so I thought, okay, I'll talk about double frees. So here I am talking about double frees. Now, some of you have heard of a Heisenberg. Yes? Have you heard of a Heisenberg? No. There's a Bohr bug is a bug that circumstances that create the bug are predictable. There's a Heisenberg. The more you investigate the bug, the closer you get to it, the more it moves around. And then there's a Schrödinger, which is a bug that doesn't exist until you read the code and realize that it should, and then it suddenly does. And I have seen a Schrödinger. I was reading the code. I'm like, what the fuck? This code can't possibly work. And then I rang up another programmer, and I'm just going the code. He's like, that can't possibly be working, but it's working in production. And the next day, a customer rang up and said, they reported this really obscure bug, which was that bug. And if we hadn't found it the day before, we would have gone. Anyway.
I found one of the same.
Yeah, they happen. All right. But a Heisenberg, they're pretty common. And in my experience, a Heisenberg is almost always a double free. So let me illustrate how that happens, because in its simplest form, a double free, bang, straight away, but not always. So I posted this code to the forum so you can follow along, but you can follow along here. So let's just set a little bit of a scene here, because all I'm going to show you tonight is code. So hopefully you can see the screen. So yeah. Okay, so I've got a couple of test objects which are both identical. They only differ in the fact that they're defined differently. So I'm only going to look at test object, and I'll come back to test object 2 later. So test object is pretty simple. I give it a name, and it has a name and a summary and also a serial number. So looking at the constructor, I keep the name, I increment the count, so I know how many objects of this type there are, which is purely for demonstration purposes. I give it a serial number, so we can track the serial number, which instance of this it is, and then I record the serial number. And when I free the object, I decrease the count. And then there's a summary that just reports what's going on with the object. This is purely to demonstrate what's going on in the code. Okay. And then I have a number of objects, number of routines. So hanging off button 1 is a very simple routine that we all will be totally familiar with. We create an object, we show a message about the summary of the object, and then we free the object. And then we create a list, add the same kind of object to the list, show the message, and then free the list. Okay, bog standard stuff. So we'll do that. Okay, so run button 1, we get a message. The message is tiny. That was something I didn't think through. I don't know how to make it bigger for you, sorry. Not quickly anyway, because it's a dialog box. Show message. Anyway, what it says is it repeats the same number twice, which I'll get to shortly, which is the object pointer reference, and says test 1. And there is one object live. And then I run the second code. We're now down here showing the message. And I see a different, the same pointer. Actually, it's a different pointer. I'll come back to that. And it's the second object. There's 2 of them. There's 2 of them live. Why is there 2 of them live? No, this is the second object.
Yeah.
And I gave it the name 2. Okay. So that's all very straightforward. Demonstrate how they work.
So your list owns the object.
Yes, because
Clause in list B would be the object.
that's correct. If I set that to false, which I'll do right now for purposes of demonstration, when I finish, I'll have an object hanging around. And so we'll get the 2 dialog boxes, and when we close the form will tell me that I have an object left hanging around. That's pretty straightforward. In the form destructor, the close, on close, if the count of live objects is greater than 0, then I get a message. Okay, so that's all really straightforward, right? Everybody happy with all that? Okay.
Yep.
All right. Now, let's turn things up a bit. On our second button, we create an object list which owns the objects. We create an object and we add it to the list. Then we show the message summary of the object. Then we don't free the object because it's in the list. And then we check that it's still in the list and it goes away. Right, still pretty straightforward. We didn't add it, we added it to the list, so we'll get 2 messages. Test 3. So this object exists at the address which ends in 120. And then it still exists as test 3 at 120, which is where it should. There's only one object. We could. Now, this is where it starts to get tricky. What if you actually forgot that you put it in a list and freed it anyway? You could do that, right? In fact, this is the easiest way to do this. I have to close this. We have no leaks. I mean, we can add it to the list and forget to free it from the list and not free it. And in which case we just get a leak. So we get our 2 dialogues, and then when I quit, we have 1 object left over. Okay. So what if we actually, instead of that, we have a list that owns the object and we free the object? What will happen when we try and look at the object?
Still probably work. Unless you have one of those debugging things that cleans everything up.
We'll get to the debuggy things later. We are definitely going there. Actually, what happens here depends. But in 3 Pascal, which is what this is unpredictable. But we have an object. Now we have a access violation because the object is no longer valid in the list. And the key is the summary calls classmate. That's a virtual object. So when the dispose happens on the object, it gets cut off from its VMT. So any attempt to use a virtual method will blow up. But the object is still there in memory. It hasn't been, like the actual record structure is still in memory. It's now labeled as available memory to the memory manager, but it's still sitting there. And if you look at it after you've disposed of it, you still see a valid object, right? But if you call a virtual method, bang, because the object has been cut off from its VMT as part of the structure.
Zero.
Shouldn't it immediately tell you that you're talking to non-existing object? Is that something that's now 3 Pascal specific, right? Because as soon as you freed it,
I think Delphi is the same. After an object is freed,
yeah,
the object, technically the object is finalized. Any long strings will be nilled, the memory will be recovered, and the VMT is cut off. That's part of finalizing an object. So it's the same in Delphi, I believe. Been there, done that many times. Right?
No, here isn't a free. It's free, not virtual. No, it's not.
Free is not virtual. No. nor is free and nil, not virtual. Which is really good because you use this all the time in practice, because I'll just put the code here. That works because free is not virtual. It doesn't do anything. If you call free on a nil object, nothing happens. Right? Okay. All right. So, but if I update the summary and take out the class name part, and yeah, disable that. Here we go. Oh no, still did. There you go. Anyway, so you get, I didn't think that did, but oh no, because I've got a cast here. A cast is a virtual method. I'm pretty sure this will work. If I get naughty, none of you ever do this, do you? You never ever do that. None of you ever do it that way, do you?
No way.
Anybody who does it this way should have their hand smacked. This is one of the reasons why, because I'm pretty sure that this is going to work this time. Yes, there you go. But you see that some of the data's gone. But still, now we try and free the object, then we're back in the virtual destructor and bang. So basically, the point of that was to demonstrate that if you immediately try and reference a freed object, whether you call free and nil or free, afterwards, very occasionally it'll look like something works, but pretty quickly you're going to go bang. That's a feature. You really don't want to be doing this. All right? All good so far. Yeah, all happy with that?
Yep.
Yeah, you're going to go bang. However, life is way more complicated than that. I don't think this particularly shows anything. I have an object list. I don't remember why I put this here. I have an object list that doesn't own the object. I add an object. I free the object. Ah, no, it does show something. Tell me what you think is going to happen. The object list does not own the objects. I added an object to the list. I show a message for what's in the object, and then I free the object. But I did not remove it from the list. Then I create a new object, show the summary of that new object. Then I get the object I originally added to the list, and show a message of this object. What will happen?
It's likely to show the big information because it's probably reuse the same space, but it's totally arbitrary. Because you clean an object and you allocate it in your memory block,
And it's
probably
a
pretty
size, so I quite like it.
and that becomes a real pain when you've got
Okay.
a list because you wind up with a looping the linked list.
All right, so the first object is test 4
Experience.
at 120, test 4 at 120, then test 5 at 120, same location. And so now A is test 5 at 120, same location, exactly what Roger said. Yes, indeed.
But that just depends on what's been allocated.
Well, we'll get to that in a sec. So what happened was I created object A, I threw it away, but I remembered a reference to it. Then I created a new object, which is the same memory size, and it went into the same location. So now both A and B are pointing at the same place. And so A appears to be valid, but it's actually B now. And then I freed B and A becomes invalid as well. So A and B end up pointing to the same thing, although you would not expect that to be the case. This is a tremendously good source of both. Because you think you have an A, but you do not. You have something else. Now, it does depend on the policy of the memory manager. So if the memory manager is doing last in, first out, it'll work like this. It is way easier to debug last in, first out with a memory manager, but not all memory managers do. This code is running on the standard Unix memory manager, and that's how the Unix memory manager works. The last piece of memory you've freed is the first one that will be allocated because your memory is actually a stack. So the memory is divided into a set of slots for different pool sizes, for the memory sizes. So if you ask for 5 bytes, it'll probably give you 8 back with probably 8 bytes of overhead or something. If you ask for, 63, you'll get 64. And if you reallocate from 55 to 63, you just get the same memory back because it's actually 64, right? But if you reallocate more, then it will allocate you new space and move stuff and do a whole bunch of work in the background. So most memory managers, because it makes this debugging easier, will give you last in, first out, right? The only difference it actually makes to you is that it makes this debugging much easier. Because imagine how much more confusing this would be if in 100,000 allocations time, we get that memory back. Actually, that does happen. You only get last in, first out sometimes. Like in simple test cases like this. But on a fully multi-threaded server, deep into execution space, you are nowhere near guaranteed last in, first out. So you can get a sudden reallocation of the memory. You've got an object hanging around in memory, it's pointing nowhere, it's gone. And half an hour later, 1 million operations later, you get that memory reallocated. In all of that time, had you used that object, bang. But then half an hour later, not bang. Right? So it's actually both better and worse, last in, first out. Last in, first out makes a double free, like predictably bad, not predictably not bad. Like from my point of view, and you'll see why, from my point of view, I want to go bang. Please give me a bang. Right? I don't want to actually, well, you'll see, because let's look at button 4. Button 4 is my nightmare. I've got 4 objects, all the same, so they're all the same size and space. I create A, I create B, I free A and I free B. That's fine. No, actually 5 is my nightmare. This is just mucking around with order, but let's see how it goes. I create A and B, and then I free A and I free B. That's fine, right? That's just normal code. I create A and I free A, I create B and I free A again, but I created B. I freed B this time, right? I thought I was freeing A, but I actually freed B. Does that make sense to everybody? I created A and freed A, and then I created B, which will get the same memory slot. And now I freed A, but I actually freed B. And then I created C and got around to freeing B, but I've actually now freed C. B and C are trash. And I create D, which is now A is pointing to D, and I free C, and finally I get around to freeing D, and bang. And I'm like, what was wrong with D? I spent half an hour trying to figure out what the hell was wrong with D. Nothing was wrong with D. There's a whole cascade of sequences that meant that D is trash, but there's nothing wrong with the code for D. It's like miles away. It doesn't even need to be in the same part of the code, because the only thing linked them is there's 2 pieces of memory with the same size, right? So this is a Heisenberg. I've now got a dead object that's got nothing to do with the code about that object, right?
So everything you did today here is valid.
Right, D is fine. D is a perfectly valid object, but I freed C, which happened to be pointing to D, but actually that was nothing to do with C or B. It was all to do with A, right? But it pops up eventually somewhere totally else. That's why I'm terrified of double freeze.
So if you hadn't freed the D there, you would have finished your program without leaks, wouldn't you?
Yes, but not without bugs.
No.
I mean,
freed everything.
it's no, yeah.
Really weird sequence.
So we'll walk through. This is 4, and we get an object of type test object, and our buttons, and then we finally blow up, and we blow up on line 243. Now, you may not be able to reproduce that because it depends on your memory manager policy, right? But if your memory manager is doing strict last in, first out, then you'll go bang on line D.
But only if it's a sequential thing like that. I mean, there could be other threads allocated.
Oh, totally. Then, and like this is for purposes of demonstration, a real multi-thread program, you are in hell. Because there's no way you're going to find, I mean, you just have to walk every single line. That's why I'm terrified of double freeze.
Graham,
Yep.
could you talk a little bit about the distinction between so the compiler has a picture of has a memory model of what's happening as described by the code, right? And then there's exactly what the bits and bytes are doing in memory when you execute the program.
Right.
So,
the compiler knows what it's doing, which is what you told it to do. The problem is not in the compiler.
so what happens when you so on line like 233, 235, you create A obviously in a memory location, and then you free it.
Yep.
Like you said, there's a virtual memory table somewhere, maybe, depending on the. So does it? If these were records, does that make any difference?
Life's a little bit more complicated with records, but no, the same principles apply.
Okay, so I guess
double freeing a record, you have less safety because you don't have a VMT to blow up on you.
So on 235, where you create B and then free A, can you say a bit more about specifically what's happening right there? So the thing is, B is being created in probably the same memory location. That's what this kind of depends on, right?
Well, so B is a different variable to A from the compiler's point of view in a different memory location, but they are both pointers to the same location on the heap. The compiler has nothing to do with the heap. It's a runtime service. So the heaps are the same. Two objects point to the same location on the heap. The compiler, because Delphi Pascal is not a reference counting compiler. If you did this in a reference counting compiler, it would go bang.
Yeah, I've been looking at a little bit of Rust just recently, and
So, but because Pascal is not reference counted, the compiler just does what you said. It takes the pointer in memory location A and in variable location A and hands it back to the heap manager and says, we're done with this. And while it's at it, it decommissions the object, finalizes the object.
If A and B at there around about the 235 mark were not created in the same location, would that change any of this?
Yeah, it would change the way it manifests. It wouldn't change the way that you were screwed up. You're screwed, whatever, somewhere, but it will change the where, which is what makes this a Heisenberg. The where is totally susceptible to being changed if there's stuff going on in the background or you have, I mean, this is a contrived example, right? It's way too simple. You'd look at this and go, idiot. But in real life, you've got an object in a list, you forgot you had in a list, you've freed it, now it's in the list and it's waiting to go bang on you, and that'll happen, 5 minutes. There's, in this really simple contrived example, you can see what's going on. But I
mean, that's why it's a perfect example, because you can like clinically dissect it and look into what's happening. That's why it's good.
Right. Okay. So you can pick this up to a degree in a real life program. You have lots and lots of objects with overlapping memory sizes, and so you can point out, you can test, right? So here's basically the same code, but when I get to do it when I'm dealing with D, I go, hey, I'm about to deal with A. Tell me that A is a test object. It will be a test object when I replace it with test objects. But when I replace it with the test object 2, it will go, no, you're not, right? So one thing you can do to deal with this is check that you have the type you think you have. Does that make sense? Do I need to actually run this code to demonstrate? No, I don't need to do that.
Because that's using an EMT.
It doesn't, yes. But now we're not worried about the fact that we have a disposed object that's gone. We're worried about we have a reallocated object that's a valid object, but it's not the one we think we have. So it's totally worth, and when I have a Heisenberg, I start doing this obsessively, making sure that I have assertions that I'm dealing with the type I think I'm dealing with. It won't point me, well, you'll see where else I go about this. Start dealing with preventative code now. You won't deal with, it won't find the problem, but it will confirm for me that I have a double free going on.
But would it also help you find where it might be as you go back?
No, it gives you places to look, but because it can be a cascade, like I know this object is screwed. That does not tell me that it was this object code, the code for this object. It was the problem. That means there's somewhere there's a.
But it's before it in the execution.
Yes, that's right. Before in the execution path, definitely. Although in like a multi-threaded server, the execution path is everything. So
But it's
didn't
not
help
a
me.
matter of when you call 3 again, is it? I mean, when you call 3, it'll blow up. It'll be double 3. But
Yeah.
I mean, if you went away and blithely used A and the value, I mean, you did used A and put it up in your dialogue box.
Yeah.
But that's not A anymore.
No,
That's
it's not.
some
You think it is
creative
right,
information.
but it's not.
So, as I said, that's what happens with linked lists, because you actually wind up with your next and you replace your next, and now you don't have a list anymore.
Yeah. All sorts of terrible things can happen.
Terrible things. Yeah.
Terrible
But
things.
but
Yeah.
actually, going back to your first statement, if you can reaffirm it, what you're saying is that if you have an object and you call a virtual method on that object, if it has been freed, it will blow up.
Yes, but not if it's been reallocated
to another object.
beforehand. That's what I'm terrified of.
Not if it's been reallocated.
Right. If it's freed and I try to use it before that memory is reused,
Yeah.
bang,
Oh,
fine.
Yeah, okay, so I thought that was the solution to a problem that I had, which is I can pass this object to this function and find out whether it's been freed or not, but you say no, because
No,
it might have been reallocated.
there is a solution to this in the compiler. If the compiler kept two things for a pointer, for an pointer to an object, it kept the memory location and the serial number of the object at the reference. Then when you dereference it, the compiler could check, is this still the same object? And then go blow up and go, no, it's not the same object. But there is no mode where the compiler will do that for you. It would double memory. It's fine. I would totally take that sacrifice. I would utterly pay that price. But there is no, haha, well, we're going to come to that. So the compiler could solve this for me, period. Okay.
Do you
There's
mean at
another-
runtime?
Yes, the compiler could, because the compiler could, like you'll see that I put a serial number in the object, right? There's a serial number here. The compiler could treat all pointers as pairs of the pointer and the serial number and have the serial number part of the variable. And then if the object is disposed and reallocated, the serial number won't match.
Well, in that direction, if we had strong syntactic analysis, I mean, maybe when you added that assert in there, I forget what line it was at, like some compilers can see you've got a dot free,
Right.
and then you're going to test, is it this object? And it's like,
Right.
we know
But in a
it's
real
not,
program, no, because this will be in some other method somewhere else. And it's just, I did a search this week and there's no code quality tools that claim to do anything about this.
in Pascal, you mean?
Any language.
What's the thing called?
Well, it doesn't happen in Rust.
D for, what is it? What's
Bring for D.
Spring for D?
I don't think,
A weak reference thing that knows when an object has been destroyed.
I do reference canning like that too. But it's not proof against reallocation because it has to check the heap location because it doesn't have a pointer unless it also dual refers to a serial number and tracks a serial number.
I have no idea how
Yeah.
it works, but it seems pretty able to destroy the object and knows it can destroy the object.
But that's in the reference, the weak references so that the reference counter is included. And
No, this is on an object, so it doesn't have a, well, I mean, something.
well, but they do because there was the new compiler that had, and that's why they introduced that.
Maybe.
For the new
Yeah,
compiler.
no, this is the one that's built. that's-
Anyway,
Yeah.
I'm not sure, but what I'm saying applies to non-reference counted languages. In a reference counted language like Java, which is my other main language, you cannot have this problem. You can totally have a different problem, which is where you think you finished with memory, but you have not. That's a totally different beast altogether.
But you don't have to free them anyway because the reference counter.
No, but you do have to remember to forget them. Right? You have to remember to forget them. There's all sorts of accidental ways to not forget them.
That's what I found. I found that there was with the reference counted language, as I said, in the old Delphi new compiler, which is now no longer used. Instead of having the objects were being left over because there was still a pointer to them somewhere. You had to do things like say with reference so that it's.
That's right, you do. Yeah. Reference scanning is a totally different beast with the inverse set of
Much
problems.
harder to work out
Right.
that you've got stuff left over.
All right. So what can you do about this? So I'm going to show you 3 things that you can do about this. Like I said, this is the thing I'm most terrified of in my code. So the first thing you can do, if you use Fast Memory Manager, FastMM, you can set this default to true in the include file, fmm.inc. If you do this, then it will fill the memory that it disposes with zeros. And you'll find out much quicker. So it's good. You haven't found the problem, but you come across the problem much quicker because the B that you think you have is gone, right? And so the memory is completely being wiped. Yeah, it's just empty.
It's not a B.
So straight away, you know that you've got a double free. Before you realize that you've got bum data that belongs on something else, you just know data. It's a lot simpler. But there's an even better option, which is to write your own memory manager. And here's the code, which fills the data with this. That is a much quicker bang, and you will recognize immediately the bang because your data will be full of EB. And you'll know immediately that it was reuse of freed memory. So you still won't pick up if the memory is reallocated before, but you'll pick it up on the other object, right? So it's pretty easy to write this object. Here's a little class with a class install procedure. The install procedure loads a different memory manager. The memory manager calls the existing memory manager, anytime memory is freed, it fills it with this EB. And so you will immediately discover when you reference memory that's been freed because it's got EB in it, which is quicker discovery than what's got nil in it, because sometimes you'll be expecting nil and you won't realize that you've got nil erroneously. Whereas the chances that you'll have memory full of EB is like vanishingly small, right? So you can do this in your code. And then you just, in your initialization procedure somewhere, you call t-scrubbing memory manager tracker.create, .install, sorry. So you can do that. That makes sense?
Okay.
Yeah, and this code, I will post this code. I wrote this afternoon. I mean, I unwrote, because it's part of a different thing that does a whole bunch more memory stuff for me. But I will post this to the forum so you can use it if you want. But now let's come to my real solution. Every single object that I define derives from this object here. That is in this is a cut down version of my real object. And I'll walk you through the features of this real object. So the object knows whether it's been disposed of. The object knows its serial number, what I showed you already, and it knows the next and the previous in the list of objects of this type. And it knows if it's being tracked, which I'll come back to. It also has in memory 2 strings. This is the name of the class, which I originally added because in Java, when I have an object, I'm looking at the debugger, I know what type it is. In Delphi, you know what type the code thinks it is. It's not the same thing in polymorphism. So I whack the name of the class in the memory of the class itself. And then when I look at it in a debugger, I immediately know what class it is. And then also I can, in a scenario where I'm looking through a list of polymorphic objects, I put debug info in the class itself. It's purely a debugging thing, right? And then there's a virtual override that you can override to fill in. And in Java, I don't need to do this because I can just see the object for the type it is and walk through its properties. But in Delphi, you can't do that. So this is a way of reaching down into the polymorphic and descendants and pulling a value up and seeing it in the debugger. Right? So
Isn't class name polymorphic?
yeah, the class name is polymorphic, but the class name you see in the debugger is what the debugger thinks it is based on the code, not what it actually is.
No,
If you disguise class name.
Yeah, but
you actually have to put that in the code, otherwise it doesn't.
yeah, this is just the way of pre-buffering class name. You can put class name in, but if you just like mouse over something, you don't see it. I wanted to see it in the mouse over. Yeah. But it turns out, you'll see that this turns out to have a second use. Okay. And then here's mucking around with the debug info so I can override it. If we've got object tracking on, you can get the serial number, though I never use it. And so let's just have a quick look through the code. I won't go through the code for that, but the unit, unit initialization is not guaranteed. So the unit initializes itself when it's first called. So the object, that when it's constructed, it grabs the name of itself, which is what we just talked about, and it initializes itself, which code we'll go and have a look. When it closes, it just closes itself up. And I'll come back to the free method. The methods of interest are the init method. So I have a dictionary of class types, which has a list of, which is a linked list pointed to a linked list of objects. So I add an entry to the dictionary if I don't have it. I count the objects, ignore the delta count. I go to serial number, see I'm in a global critical section. Then I add it to the list, the linked list of objects, and then I'm done. And by the way, while we're here, if particularly in JD unit testing, the serial number allocation is really, really consistent. So you can put a breakpoint right here and a number here and actually break on the construction of a specific instance of an object, which I often end up doing in tracking object. And I can also track when the object is freed and breakpoint for a specific object. It's occasionally useful, and so I left it in for you. But the most important thing is I now have a list of all lists of live objects in the system. It has a CPU penalty of about 0.5% of your program execution time, which is almost all entering the critical section. When the object closes, it grabs itself out of the dictionary and removes itself out of the linked list. And that's all it does. But when we close up, if the program has said it wants a memory tracking dialog or filling a memory tracking file, you'll get a list of every live object that's left in the system. And as well, you'll get the serial numbers, so you can go back and track the individual objects, and you'll get the debug info in the log file. The debug info has a separate use. I can see what was in the object that's left over. So the first thing about not having any double freeze is not to have any leaks. right? Total, that's my standard now. If I'm debugging, developing, whatever, writing the unit tests, and I find a memory leak, everything stops while I fix the memory leak and figure out why I had a memory leak. Because that's by far the most effective way not to have accidental double freeze. That makes sense? That I am 100% confident about my memory management. And so that's why this code, at every time when the program, unless I control F2 the program, I will get a dump of objects that are live. And generally I often get like 100,000 objects in the dump because one object leaked, right? And it had references to about 100. So you work through that. Which one was it? Which object leaked? Which is the root object of this set? And then the debug info will tell me which one it was logically. And I go look in the code and go, oh yeah, it did leak. I got it wrong. Right. So that's the first thing that I do. That all makes sense. And honestly, I would never develop any code in Delphi, in Pascal or Delphi, without every single object hangs off this object because of this. Yep, that makes sense. Okay. And this code, I posted this code to the forum. The other thing is that I have a override. I wrote my own free routine. So in the base object, I never call free and nil. I call .free. So I get this free to run. And when this free runs, that's not what it was. This free runs. I do if assign self, that's the dual thing. So I look to see if it's been disposed already. And if it has been disposed already, then I grab the name of the class, which is probably still in memory, probably. And then if it is, then I call a free callback so I can log it. This is the single most important thing I want to know, my code running live. If this code fires, I want to know. So it goes straight into the application log, right? In the callback. And otherwise, and then I throw an exception. Attempt to free a class again of type X. Which is way more useful than access violation. Right? I mean, it won't pick up if the class has been reallocated, right? But it will mean that immediately I see an access violation, I know it's double free because it tells me that. And I'll demonstrate that in a second. Otherwise, we just go ahead and destroy the object. And so just to demonstrate this, the last is a double free of one of these types of objects. Button 7. Attempt to free a class again. Oh, I left the memory manager in, so I got crap. There you go. You know exactly. I'll take that memory manager out. Where did I do that? Oh, yes, I did it down here. We'll take that out and we'll do it again. So, I mean, these are things to mix and match depending on the debugging techniques, right? So I'll come back to the debugging a bit later, but typically I will get a message like this. Attempt to free a class again of type T-base object. So, in the base unit, all of the functionality, just get rid of that. All the functionality here in the base unit depends on being in debug mode. No debug mode, no functionality. It's just a transparent object that, no, it may do. This is annoying. Whoops. I'm running on the pre-release version of Lazarus. Don't ask me why. And it has a couple of bugs. Yeah, you can use the object counting independently of debugging, and sometimes I release an object, a server release with object counting included. So that's what I wanted to show you. The problem, why I'm so terrified of the problem, and the tools that I have to deal with the problem. You don't need to use my tools, but the thing that's always bugged me about this is code analysis, code debuggers, they can't touch this problem because the memory is always valid. It's your references that are scrambled only compared to what you think. Of course, in the end, something blows up and it tells you something blew up, but that is not the source of the problem. It's the end of a cascade away from the actual problem. So that's what I wanted to show you. I hope that was useful. You're welcome to take use of the code that I put on the forum to help you diagnose those kind of problems. I don't know how many of you have ever had this problem. It's stunningly easy to create for me.
I've seen the few cases, but well, I always had to pass giving check for memory leaks. I've never run into that.
Then you are lucky that you haven't had the cascade, although probably you have.
I've had the problem, but if you get rid of the memory leaks, it means that you be more careful about your memory.
Yep, that's exactly right. Yes.
You're saying that you always use this base object, but if you actually use another object, there's base on your base object.
So when
it's okay for your business object, so
yeah, not for VCL stuff, but VCL stuff is usually pretty reference. Its life cycles are managed by the form that you're in. And the only exception then
about things like India and stuff like that. And I'm not quite sure that India properly.
I run my own version of Indie that does.
Right.
And actually, for another whole set of reasons, I have a T-stream inherit a whole alternative streams that do, but they exist for a different reason, to do with matching the Java streaming API, which is better, but less convenient, but better at handling network streams. Anyway, I hope that was useful.
The reason is that I still don't understand after 25 years. We get told not to use free and nil. If you used free and nil in your code instead of free, would that have?
That wouldn't make any difference.
Well, it would, because it would have nilled a.
Yeah, okay. In this specific test instance, it would totally have made a difference. In this really, really dumb case here.
Yeah.
There.
Yeah.
Sorry, there. Yes, because A would be nil and the free would go nowhere.
No longer be a reference to.
Yeah. And so in this simple test case, you're right. Free and nil would mean you wouldn't have this problem. But a real code where you've got copies of the same object in multiple places.
But the free and nil would not have helped when you then tried to nil it off the list. Because the value is on the list as well.
Yeah. Free and nil is about the variable, not the memory location.
Yeah.
Oh, right.
Yeah. So I use free because then I can get that other code to run. And I have other things as well, but I won't talk about them. So I'd never use free and nil. But if you use free and nil, it will solve a fraction of the cases, but not the real cases where you have multiple variables pointing at the same objects. You know, passing variables around. So what we do with objects. So yeah. If you want to use that base object, you can't use free and nil, because free and nil type cast is in system.pass and casts the object to a T object and calls the other free. It doesn't call that free, so you miss out on the advantages of that free. And you also miss out on, I don't want to bother with the other things you miss out on, but
so does your free throw away a little pointer like the free one that does?
Yeah, it does that too. Yeah.
Or doesn't try and act on the little pointers more.
Yes, it doesn't. It doesn't do anything with nil pointer. Yeah.
So what are your objects doing to these business objects? Or just
yeah, like I'll just give you a sense. My server starts by loading.
So the server object, which is one of those basic.
Yeah, it loads a bunch of JSON and XML files and holds them in memory. there's 18 gigabytes of objects in memory, and then requests are made, requests are processed, responses are sent out, logic is executed, billions of objects going backwards, coming up and down as it happens. But yeah, this is a technique that belongs inside business libraries. Yeah, I don't bother with any of this stuff when I'm writing actual user interface code, because T components are managed, life cycles are managed by the form through T component list. So I never think about those. And I'm not in the habit of creating and throwing away T components. Like, I would rarely use a T component. Probably the only time I use T components directory in code, I like dialogues, file open and file save dialogues. Other than that, for me, it's like all my business objects will run on the server context, so they're never going to touch the VCL. And for me, that's a pretty hard separation. And then, yeah, in the server side, it's all indie based server and yeah, business objects at scale. So.
Yeah, it makes me wonder sometimes when I open a bit of code that I haven't written and I don't understand terribly well. And I put fast FM on it when I run the program and I get all of these.
I mean, if you're writing, if you get these problems and you're writing a graphical program that doesn't have a lot of logic and doesn't have a long persistence time, why the hell not leak? Leak to the heart. Why bother freeing stuff? It can only cause you problems, right? You might as well just leak them. And then you can't have memory going around in circles because you're just accumulating memory. Eventually that'll cause you a problem, and then you're really in hell when it does, because you've never been disciplined about your objects.
That's when you start with a small program and over the years it turns into a big one. And
Turns into a monster.
and then
That's exactly right.
nightmare.
Yeah, so I would always be disciplined with my objects, but it's pretty hard. Yeah, I mean, you have to have your nose rubbed in it a few times to get to that point. And there is very little price when it's a small program to just leak.
Yeah, I know. In the code that I've written myself, I've always been pretty strict like John. Fast every run as soon as everything that has to be fixed.
Yeah.
Some of it's been server code and some of it's been VCL code. So I just use the same policy all the way through, just because that's
That makes sense. With regard to FastMM, I used to use FastMM, but the code I have, because it only does a few things, does it a lot quicker than the same FastMM code. Right. And so I can afford to run my code in production, but I can't run FastMM in that mode in production. It's a huge drag on the system. So that's one reason.
which version of FastMM.
Oh, I don't know, it's the latest. But I'm running, when I run FastMM 4.72, because it's the one that's been ported to Lazarus to Free Pascal.
Right.
But it's only Windows only FastMM.
Yeah.
So off Windows, I'm using CMEM, which is a standard C memory library.
No, just because I've used FastMM for a long time. And they've got FastMM 5 now, which is
Yeah, I don't know.
a one, which is quite a rewrite, and it's just curious to know.
I don't know anything about that.
Does Grahame?
Yep.
Does not operating system, does the chip hardware that you're running this on make a difference? Or operating system, I guess, like, is it different on Mac at all?
Nah, the difference is in your memory manager. Otherwise, it's heap and registers and local variables And so the only thing that I found that varies between compilers and between operating systems and between chips is the memory reuse policy. So some, like I said, the Unix CMEM and some variants of FastMM use last in, first out, but then other chips, other memory managers use other approaches. And some of them are specific to specific chips, but they don't have to. They could choose whatever algorithm they want to manage the memory space. And like I said, either CMEM and FastMM don't always do last in, first out, depending on what's going on internally. Like if they do a reorg, they might disappear for a while and do a reorg. And you might lose, like this happens, you might lose 100 milliseconds while it reorgs memory when you did a memory allocation. So memory allocation usually takes a nanosecond, takes 100 milliseconds because it's chosen to reorg. You won't get last in, first out when that happens. But yeah, none of that is chip specific. And I mean, this is an Apple Silicon chip on OS X using Unix. Is about as far different as you can get from a standard Delphi program, but the behavior is basically the same, except for the memory manager.
Do you think I could share my screen for a second? If people
Are you
don't mind.
looking at the FastMM options? Yep. Oh, that's you. Okay, sorry.
Just to show you, I've got a 4K screen. Does it come up okay for people?
Yeah.
You can see that?
Yeah.
It's just I know about 1 centimeter of rust at this point. And so on the left here, it's like a hello world program. And when you you create a variable here, S, which is a string. And when you pass, so unless you pass a reference, if you pass a variable to a function in Rust, as far as the main body of the program is concerned, that doesn't exist anymore. You've handed the variable to that function, and the function knows about it, and you don't have it anymore and cannot reference it. So on this line, the drop is the same as basically kind of like free. It's removing it from the consideration of the compiler. And on the right hand side is the error message that the compiler gives you that when you drop S, that variable has been moved into that function and doesn't sort of exist in the program anymore. And if you call it again, it says you're basically using something that we don't have. It's gone. So you could create, I hope this works, well, this won't work here. You can't do T equal to S. Because S doesn't exist at this point in time. You can't do S.clone again because it doesn't exist at that.
What if you do it before the drop?
That's very confusing.
Yeah, I was getting to. If we move this, I'm not sure I'm writing the right thing.
Get my head around Rust.
I think maybe it's clone S.
I mean,
Let's try that.
I don't understand what the compiler's saying here, because it also says that it moves after print line, but you can use it after that. But then when you use the second drop, it says, well, you can't move it there, you bozo, because it's already been moved. But it was already moved twice. That's confusing. No, I think drop S is the magic thing.
Print line's a macro, but not a function. I'm not sure what's happening now. I don't know that much about it. But you can give a reference into a function, and then you have to tell it about lifetimes. And the interesting thing I thought, because I started finding out about God, okay, there's variance and covariance, and it's got to do with subtyping in object-oriented programs and what you can, the things that you can substitute for other things into functions and all that sort of thing. And I was kind of confused about that, and or learning. But anyway, subtyping is maybe kind of sometimes the same as subclassing, but in Rust, lifetimes are subtyping, if that makes any sense. And you have to be bothered about the things that you can hand to functions. Like, anyway, sorry, I didn't mean to drag us this far off. I just wanted to show that it won't let you it's concerned about ownership and lifetimes and that sort of thing, and maybe one day there's some way we can have also nicer things in Pascal as well.
Oh, no, this is not right.
In a fantasy world, we'll get reference counted Pascal with the same compiler. The problem they released, Roger talked about it before, a reference counting compiler, but it came with too many other prices. If I simply had to give up using records and could only have objects and got reference counting, that'd be sweet. I'd love that. I very rarely use objects because I partly have the fantasy that one day I'll get there, and also I have all my object stuff. But
anyway, sorry, I'll stop sharing. I just wanted to
it's interesting though. I have more of a read about Rust.
They've just started up a user group here in Perth a few months ago, so it's interesting.
One of the best bugs I've seen that sort of a bit like Heisenberg was on an ICL 1903 COBOL, and the program was outputting a string. Outputting a number was the total of a column, except the first digit was always one less than it should have been, no matter how many digits it was, including if the first digit was 1, became 0, even though the leading zeros were normally suppressed. And I've got to figure that the only way something like this is happening is, well, we ended up searching through all of the array searches, and there was something where it wasn't terminating at the end of the array, and just kept searching through memory until it found a match. And then it overwrote, it incremented something, and it incremented an opcode. And yeah, so it was actually repeatable, but it was just a really weird problem. It was ages after the cause of it.
Strange. The Schroden bug I talked about before is also my favorite bug ever. Kevin wrote it. John knows Kevin. Yeah. He defined a global variable named R. And then he created an object with a member named R. And then he created a whole bunch of functions, both global and object functions, that took a variable R, sometimes which were by value and sometimes which were by reference. And every time you thought you were dealing with the same thing, but you weren't always. It's glorious bug, that one. And there's no way that I would have known what to look for if I hadn't found it by accident.
What was R short for?
It was a pointer to a record which held a clinical, this is the scary bit, it held a diagnostic result, which was the actual crown jewels, and totally has to be the right thing, because otherwise you issue the wrong thing on the wrong patient, which was always our biggest nightmare. And I'm just like, Kevin, what the fuck? I was debugging something, and I was doing what I love to do, which is watching object serial numbers and counters, because I was looking for a memory leak. And then I realized that I had more than one object around, And then I'm like, oh, and then I'm looking at the R value, and I'm like, oh, yeah. I started, yeah. Anyway. So my favorite, and then my other favorite bug, back in 1999, we were releasing a client app, and Windows 2000 was one of the Windows releases was coming, and there'd been a report in the press that if IRQ7 fired while the clock was ticking over to midnight, then the PC would hang. So we released this new client for a 24/7 business, and it had been a big upgrade, and a number of the programmers were on site because we really didn't want it to go wrong. And suddenly it just went blip for a second and it stopped. And okay, and then it suddenly stopped for a minute.
What time was this?
1999.
At what time?
Or it just stopped for a second, and then it suddenly stopped for a minute. And we didn't think to look at the time. And I was like sitting there with Kevin, me, and two others looking through the code, going, what the hell? Why did it stop for a minute? What was wrong with the server? Why looking at this, the server was doing nothing for the whole minute. And then 11 o'clock, boom, 11 p.m., nothing. So the whole system stopped for an hour. And we're just like, what the hell? And we couldn't find any. And 53 hours we went trying to find this. The whole time the system was like lagging occasionally, stopping for a minute randomly, and then stopping at 11 p.m. And then finally 2 a.m. on the second night. I don't think any of us had slept more than a couple of hours here and there. Kevin found that one of the programmers had read about the IRQ bug and put in a prevention in the system and said, if the time is 23 and the minutes are 59 and the seconds are 59, then just hog everything, that real low level Windows system call. And then when that finishes, then you can let go of everything, except he got ors instead of ands. Oops.
It was supposed to stop.
He was the office man, doesn't he?
Yeah. And so, yeah, so we got, yeah. Yeah, that was not fun. That's really interesting, the way Rust works. I've just been reading about it. It's not using garbage collection or reference counting. It's manually reference counted, but only one thing can own the object. Terrifying. I think I'd write this garbage collection.
You can have references, but you can't have I don't have it in my head, but you know, there's a difference between owning references, owning mutable references. Everything's immutable by default unless you declare it as mutable.
Interesting.
Yeah, if you have a reference to it but you don't own it, then you can't destroy it. So double freeze can't happen. Well, at least not by different threads, for example.
Yeah, yeah. I mean, that I do like that part of it.
It's a shame the syntax for Rust is so C-like. I want to like it. I really do. I play with it for a while, but I just, yeah, it's hard to read. And for me, code has to be easy to read. You know, I don't care how hard it is to write. It's how easy it is to read that matters.
So in your philosophy of easy to read, Vincent, do you count Java or C# as easier to read?
Yeah, well, I can read C# and Java. I'm not a fan of Java, just for historical reasons, but Yeah, I don't know. Rust is kind of like it's a bit like Dart as well. You know, like just too many funny like ceremony sort of things that I'm looking at that example that Paul showed. You know, just to create a string. You know, string from. You know, just say it equals and the string, and we can surmise that was a string from call. You know, there's too much ceremony there. So,
You can have a like a it's not correct to say C style string, but you can just put the brackets, but you would have a reference to a memory location, which is different to a capital S string, apparently, I think.
yeah,
But
I think my main problem with Rust is I haven't got time to look at it properly, like to get really into it.
I think it's curious you said C-like, because I think it's very Pascal-like.
Some things are, yes, yeah.
I mean, where did I write somewhere that I think it's like back in the day, you as a kid you learned BASIC, and then there was evil C and C++ on one side that looked like a pigeon had stepped in ink and stepped all over the page, and Pascal, which was elegant and readable. And now these days, I think the BASIC is Python and JavaScript, and I kind of got a feeling that Rust is a little bit Pascal. Like I got a feeling that it's there's some synergies there.
I've kind of come to the conclusion that I don't have the capacity to get involved in another programming language. I already have too many on the go. On a daily basis, I'm writing Pascal, C#, TypeScript, and JavaScript. You know, which the number of times that I get things around the wrong way. After doing C# for a while, then I go back into Delphi and start declaring variables the wrong way around. Type name and then the variable name. And then back to front. Just switching between them all the time. It's I don't know, maybe it's an age thing, but I'm finding it harder and harder.
But
while I want to be up to speed with Rust and other languages, I just don't have the time or the capacity, I think.
But between those three, do you find things that are, what do you call it? Like, not synergies, like things that are essentially the same across those three different languages, where you recognize the same sort of pattern or idea? Or
yeah, I mean, I can read the code, and it's just I find with Rust and some of the new languages like Dart and that, and just find it takes me longer to understand the code. Like, what's it doing here? Because the semantics of things are a bit different as well, especially with Rust. As we just saw with the Hello World.